Hello and welcome to this course on numerical methods. In the previous couple of lectures, we have been talking about various initial methods to get you started with understanding what these numerical methods are. In this lecture, I am going to cover an iterative method, that is the method that we have discussed to calculate square root of 2. Okay. Before we go that, let us just do the couple of definitions. The definition of error is shown over here. We are going to mostly use the definition of absolute error. Okay. The definition of absolute error is nothing but the true value of solution minus the approximate numerical solution that we have at this point of time. Okay. So, that is the definition of absolute error. Relative error is just the true value minus the approximate value divided by true value. When it comes to errors, it does not matter whether the error is in positive direction or the negative direction. What matters is how much the error differs from how much the absolute value how much the approximate value differs from the true value. Okay. So, it is their absolute difference that matters. So, we have this absolute x minus x a or x star minus x a as the definition of the error. Keep in mind that there is this absolute sign over there. Okay. So, now let us go over the example and see how we can use our numerical technique in order to figure out how to do this solution. Okay. So, let us take the square root example. The square root example, as we had said, is an iterative example. So, we start with an initial guess x I, okay, and iteratively use this equation in order to improve the initial guess. Okay. Let us do it in a very structured manner. Let us call this iterations. Okay. Let us have the guess which is x I. Let us have the next column which calculates 2 divided by x I. Okay. And after that we will have to calculate the error. Okay. Iteration 0, the value of x I is 0.5. Okay. So, initially we have the guess as x I equal to 0.5. Okay. And what is the error? The error, let us use a calculator in order to calculate. The error is going to be calculated by square root of 2 square root, okay, minus 0.5. Okay. So, the error is 0.9142. Okay. So, these are the initial conditions. So, let us now do this iterative solution procedure in order to use this algorithm to find square root of 2. Okay. So, the first step is to calculate 2 divided by x. Let us do that, and that is going to be 2 divided by 0.5. Answer to that is 4. Okay. Then we are going to take an average of 4 and 0.5, that is average of this guy and this guy. So, let us also do that. So, 4 plus 0.5 equal to 4.5 and divided by 2, that is 2.25. Okay. So, the value that we are going to write over here, this value is going to be 4. Okay. Then we are going to take the average of 4 and 0.5. So, the value that we will get at iteration 1, that is x I plus 1 is half multiplied by 0.5 plus 2 divided by 0.5, which is 4. So, half multiplied by 4.5 and that is 2.25. Okay. So, what is the error? The error is nothing but 2.25 minus square root of 2, which is equal to 0.8358. So, the error is going to be 0.8358. Okay. Now, what we are going to do next? We are going to do next is calculate 2 divided by xi, okay, which is 2 divided by 2.25. Let us clear this. 2 divided by 2.25 equals 0.8889. And we will add 2.25 plus 2.25 equal to this divided by 2. That is going to be our next guess. Okay, that is 1.5694. That is the value that we get at iteration number 2. Okay. What is the error? The error is minus square root of 2. So, minus 2 square root equal to 0.1552. This is the square root. So, what is going to be 2 divided by x? It is just going to be 2 divided by 1.5694, that is going to be equal to 1.2744. Okay. So, we are now going to take the average of these two values. So, 1.2744 plus 1.5694 equal to divided by 2 equal to 1.4219. 1.4219, that is the value that we get at iteration number 3. Okay. Again, let us calculate the error, and the error is 0.00767. Okay. And let us now calculate what is 2 divided by x, that is going to be 2 divided by 1.4219, which is 1.4066, 1.4066, and the average of those two numbers is 1.4066 plus 1.4219 equal to, and then divided by 2 equal to. So, 1.4142, that is iteration number 4, iteration number 4, 1.4142. Okay. And we will also find the error, and the error is minus 2 square root equal to, so the error is 2.078 into 10 to the power minus 5. 2.078. Okay. So, we now need to decide whether or not this error is sufficient for us. If yes, if we wanted to find the square root of 2 within, let us say 10 to the power minus 4 as the error, we can say that we will stop at this stage. If we wanted to reduce the error even further, we will not be stopping at this stage, we will do one more calculations, which is what we will do right now. Okay. So, it is 2 divided by 1.4142, and again there is a problem with what I am doing and I will explain that to you in a bit. So, this is the value plus 1.4142 divided by 2, okay, and then the result is 1.4142 again. Okay. And we will see that the error would not decrease as we expected. Okay. Well, actually error did decrease, I am sorry. So, we did see a decrease in error, but that is we were a little bit lucky in this decrease of error, and the error is 6.5 into 10 to the power minus 11. Okay. Why did I say that it is not, I am not sure whether the error will decrease or not? That is because all these while what we were doing is, when we were getting our solution, you see that the solution that we get is reasonably accurate for the 5 digit 5 significant digits that we have used. 1.4142 we have already used 5 significant digits, and the error that we are getting is 10 to the power minus 5. So, the error that we are getting is in the digits that would have come over here, okay. But because we are chopping off over here, okay, we are not guaranteed that what we get over here is something that is going to be correct or not. That is because we have lost this particular information. So, in this example what we have followed is what is known as a 5 digit arithmetic. Okay. Using a 5 digit arithmetic, we will get only up to an error that is shown at this level. We should not be using the 5th iteration if we are using 5 significant digits in computing our solution. Okay. So, what did we do in this particular lecture? We took up the example of square root of 2 and showed how we can calculate square root of 2 using an iterative procedure. In this iterative procedure, we already knew what the value of the square root of 2 was going to be. So, the error that we calculated was the xi minus square root of 2, the absolute value of that, and that absolute value, as you can see, kept decreasing as the iterations kept increasing. Okay. Now, the next point is that the true value square root of 2, we knew the true value, but lot of times the true value is not really known. If the true value is not really known, then what do we do? So, what do we do if we do not know x star? If we do not know x star, then our error is the difference between current iteration value and the previous iteration value. Okay. So, let us go back to this example. Okay. Let me erase a few things. Okay. I will call this what is known as a true error. Okay. And in this column I will call something called an error. I will just call this an error. This is our working error. Okay. And as we saw in the other slide, that working error is xi minus 1, absolute value of that. Okay. So, for 0th iteration, there is no definition of error because x0 minus x minus 1 does not really exist. We are only starting with x0. Okay. For over here, the error is 2.25 minus 0.05, sorry 0.5. So, the error is 1.75. The error over here is 1.5694 minus 2.25. So, 1.5694 minus 2.25, which is 0.6806, 0.6806. The next error is 1.4219 minus 1.5694 and that is 0.1475. Okay. The next one is 1.4142 minus 1.4219 and that is 0.0077. Okay. And at this stage we are not going to stop because the error that we have is still quite high. We want to decrease that error further. So, we would have done the fifth step if we were going to do the practical way of solving this method of solving this solution solving this problem, and with this practical method our last error is just going to be the difference between the two, and with this finite precision arithmetic the difference between the two is going to be turn out to be 0. So, our final solution for square root of 2 we will have as 1.4142. Okay. So, this is the overall procedure for an iterative example which is to find the square root of 2 using the Heron's algorithm. Okay. So, I hope this particular example clearly shows you how to work with an iterative method, as well as it gives you an idea of what the errors are and how do we use the errors, and you would have learned the difference between the true error if the true value is known, or more appropriately the iteration error, which means you are calculating the difference between the current iterative value and the previous iterative value, and you keep repeating that until your solution converges. Okay. So, this is the overall procedure that we are going to use in all the lectures that we are going to do from this point forward. Okay. And just a graphical way of looking at it, this black line over here shows how the value of x changes, this red line shows how the value of 2 divided by x changes, and as you can see the error keeps decreasing as the number of iteration keeps increasing, and we are going to get to the square root of 2 value within 4 or 5 iterations. With that, I come to the end of this lecture and see you in the next lecture. Thanks and bye.